The key takeaway from the last two set of videos is that the electrical potential by a dipole and a single charge is not the same. The pattern or the space, how it alters, they're different. So what are the differences? First thing is nature of source. In dipole, obviously it is dipole. So we have two equal and opposite charges separated by a small distance. For a single charge, it's single charge. Dependency of distance, it is going to follow the inverse square law. Here it is not going to follow inverse square law. It's decreasing at a rate of 1 by r. Are they symmetrical? Yes. Single charge creates a spherical symmetry. So you can rotate it anyhow you want it. The pattern will look the same. While here it is cylindrically symmetrical. That is, if I take up a cylinder, this will be the axis passing through both the centers. If I keep the charge at, along the axis, so you rotate it anyhow you guys want it, the pattern will not change. Right? We have seen that. Okay. So that is your cylindrically symmetrical. That we have seen in the last chapter also. Regarding zero potential, along the perpendicular, basically your equatorial line. So along this line, the dipole has a zero potential throughout this line. You can write or use the phrase equatorial. It is zero for a single charge at infinity. The potential is zero for a single charge at infinity. For this, it is all along your equatorial point. Simple reason being, you have equal and opposite charges, they are pulling and one is pushing and so on and so forth. So in terms of force, in terms of potential, we have one positive, one negative. Any kind of algebraic sum of plus 1 minus 1, the direction does not matter. So this is always going to be equal to 0 because this is algebraic sum. This is a scalar quantity. So everything is interconnected. Okay, so now it's time for you guys to pause and have a look.